Hi, my name is Tom Lever. In this tutorial, I would like to share some simple modifications of the darknet YOLOv4 deep learning framework that allow the darknet executable to point out a moving dog in a video that is darknet, is watching. I wrote these comments in method main of darknet, submethod run detector, submethod demo, submethod draw detection CV version 3. As you can see, I have an open YouTube browser featuring The Best Dogs of BBC Earth, a BBC documentary on how dogs see, ironically, at least at this point in the documentary. Now, I'd like to explain my modifications. You can see also that I have darknet running right now, and in the background here is an OpenCV window displaying the captured desktop, including the documentary window, and detection bounding boxes. Specifically here, I think they are laptop and, what's the other one? Let's go here. TV monitor is dark blue, laptop is light blue. This is a bit chaotic because it seems to be identifying desktops within desktops. But if I minimize my OpenCV output window, then I can see much more of the desktop and can see the major detections, and there's less visual chaos. Let's bring this just back out so we know it's in the background. Okay. So, explaining my modifications, I asked the method getCaptureFrameCV to return an OpenCV mat object representing my desktop instead of my webcam. I'll explain this more later. At this point, I'd like to say that darknet is presently running in demo mode behind this Visual Studio 2019 window. It will start tracking a dog in this visible documentary when it first sees a dog after I resume the YouTube video. That being said, presently, for every frame in the desktop capture, darknet is redeclaring and redefining cursor X coordinate and cursor Y coordinate based on where I manually move the cursor. Also, for every frame, darknet is also redeclaring and redefining X coordinate of closest dog and Y coordinate of closest dog as some nonsense integer, given that the positions of the cursor on the desktop range from 0, 0 in the upper left-hand corner to horizontal display resolution by vertical display resolution in the bottom right corner. So, big picture again, for every frame, darknet is redeclaring these basic variables, is capturing the cursor x and y coordinates, and is looking for the nearest dog relative to those x and y coordinates at the beginning of the frame. So if I press play and it finds a dog, then it will darknet will change the position of this pointer, this cursor, to the upper left-hand corner of the dog, and then the next frame will reset cursor x and y coordinate based on where darknet moved the cursor at the end of the previous frame, and then it'll look for the closest dog identified in the present frame relative to the cursor position at the end of the last frame / the beginning of this frame. And so hopefully the cursor will only be moved a slight amount because it finds the nearest dog to the old cursor position and then resets the cursor position. So hopefully the bounding boxes don't move all that much, and the cursor keeps identifying the same dog as the bounding boxes move a little bit and the dog moves a little bit in the video. So it's all proximity based. Okay. So let's now scroll down toward the end of this for loop over the number of detected objects. So a for loop over the detected objects in the present frame. Scrolling down. Here's some other comments and code that I wrote. All right. So here we are toward the end of this for loop. It actually ends, I think, here. All right. So toward the end of every iteration in time of this for loop, the for loop being over detected objects, the for loop and all this code is found in Draw Detection CV version 3. If the present object is a dog, then if a dog has just been found for the first time this frame, darknet sensically redefines x and y coordinates of closest dog. They were nonsense before. Darknet sensically defines the x and y coordinates of closest dog to represent the position of this first and closest dog relative to where the cursor started out this frame. If a dog has already been found in the present frame, darknet updates x coordinate of closest dog and y coordinate of closest dog, depending on which dog is actually closer to where the cursor started out at the beginning of this frame. This finding the closest dog and moving the cursor slightly to the upper left-hand corner of the bounding box around that closest dog allows darknet to track, ideally, hopefully, the same dog between frames. Again, we assume that the bounding box doesn't move all that much, is still present, and the dog presumably hasn't moved all that much in the video between frames. Okay, let's now proceed to outside the for loop over the detected objects for the present frame. Here we are outside the for loop. If darknet has identified a closest dog to where the cursor started out this frame, then darknet repositions the mouse cursor to the upper left corner of the closest dog. So that's a walkthrough of the comments and the code snippets that I added that allow darknet to capture my desktop. Actually, I didn't go over the desktop capture yet, but we captured the desktop in another method, and then darknet identifies objects, including dogs, within the desktop capture, within each frame. And if it identifies a dog for the first time, it takes over my computer and moves my pointer cursor to the upper left-hand corner of the bounding box around that dog. And in subsequent frames, it finds the closest identified bounding box around a dog and moves the mouse pointer to the upper left-hand corner of that bounding box. And hopefully then the mouse cursor will track the same dog. Okay, so I think I'm ready to demonstrate the artificial intelligence here of detection of dogs and basic robotic control, sort of my computer. So I am going to minimize the OpenCV output display. We can see darknet is still running. Here is the console output. It's identifying laptop and TV monitor with confidences. Confidences each are objectness score times class probability for the respective detection. Right now it's only running at 15 frames per second. That I think relates to running OBS Studio. Possibly using the same threads. Maybe there's some multitasking on the same Windows API threads. I really don't know yet much about the anatomy of screen capture, of video processing, of multi-threading applications. But darknet is running, OBS Studio is running. We're getting 15 frames per second, which is good enough. Everything is minimized besides this fairly static Visual Studio 2019 window and the documentary window. All dogs that appear will appear in this main video frame. I cleverly hid dogs in other thumbnails for videos out of sight to you and to darknet. Okay, so I'm going to press play, and then I expect that darknet will start identifying dogs in this video frame and then moving my cursor to the upper left-hand corner of that dog or those dogs. So let's give it a shot. Pressing play.
And with this comes a whole new world of sensory stimulation.
There you go. One note I would like to make is that it would be fairly simple, I think, to revise these code snippets to work with the center of the bounding box. But for future applications, I think upper left-hand corner is more valuable to me.
But that doesn't mean that everything is black and white. She does see color, but mostly just blues and yellows.
I really think it's cool that we're talking about dog seeing and talking about computer seeing. I will be able to take back control. For example, right now, where there are toys being displayed, as opposed to dogs, because there's no per frame resetting of my cursor position. So I'll take that opportunity to pause this documentary and take back control of my cursor, and I think I will load back up this OpenCV output and navigate back here. As you can see, I've taken the opportunity to reset my desktop to show the method getCaptureFrameCV in image opencv.c++ in the darknet solution, and to show a particular article on Stack Overflow, as well as documents in the Microsoft and OpenCV APIs. So at this point, I'd like to show you my code modifications to the method getCaptureFrameCV that change darknet to work with captures of my desktop as opposed to webcam frames. The below code snippet modifies method main in darknet, submethod runDetector, demo, fetch in thread, get image from stream, either sized or letterbox, and submethod getCaptureFrameCV. The below code snippet modifies this method getCaptureFrameCV to return a matrix object representing the desktop instead of a matrix object based on the video capture object cap defined in line 33 of demo.c and line 165. So here's the initial definition of video capture object cap, and it is a video capture object with a input parameter to the constructor of cam index equals 0. And I am basically overriding this statement up here. So here the value pointed to by cap is stored in this new video capture object, and then this matrix pointer is adjusted from null pointer to a memory location representing the value of this cat video capture object. So we're overriding this set into matrix object mat. And matrix object will eventually have a data pointer that points to a bitmap representing the desktop as opposed to a webcam frame. All right. So the following code snippet, as well as the code that I showed you to actually do the semi-robotics of moving my cursor, all of these code snippets require including windows.h before some other header files. I'm not sure which, probably the OpenCV header files, but for this tutorial, I've just included windows.h at the very top of this C++ source file, image opencv.c++. At this point, I'd like to walk through the following modifications to this method. Get capture frame CV. So I'm really just implementing this solution to an OpenCV desktop capture inquiry. But I've rewritten it to be more intuitive to me, more well commented, more English. Okay. So first, based on this solution, we retrieve a handle to the desktop window. The desktop window covers the entire screen. The desktop window is the area on top of which other windows are painted. Then we retrieve a handle to a device context for the desktop window. We create a handle to a memory device context compatible with the desktop window. We set to color on color the bitmap stretching mode in the specified device context at the handle to memory device context compatible with desktop window. The stretching mode defines how the system combines rows or columns of a bitmap with existing pixels on a display. When darknet later calls in this method get capture frame CV the stretch BLT function. So using the Windows API, the darknet will capture the desktop, I believe, in raw pixels. Going quickly to Windows display settings, here we have an option for change the size of text, apps, and other items set to 150%. If I go smaller, then the text will be very small, almost unreadable on my fairly large monitor with high resolution thanks to my NVIDIA graphics card. So darknet and the Windows API, I think, are going to capture the desktop bitmap in raw pixels. But I believe that the OpenCV output display and darknet work, maybe just the OpenCV output window, but they work in view pixels. There are 1.5 raw pixels per view pixel in any one direction. So we're going to have to do some stretching to convert the desktop capture bitmap in raw pixels to view pixels so that when the image is displayed in the output, the output image is not truncated. I also had to deal with view pixels when I created the C# Universal Windows Platform app to assist with labeling oak leaves for a custom darknet dataset. Okay. Next, we retrieve the coordinates of the desktop Windows client area. The client coordinates specify the upper left and lower right corners of the client area in view pixels. No, sorry, in view pixels. But while getClientRectangle captures coordinates in view pixels, again, I believe that darknet will capture the source bitmap of the desktop in raw pixels, and then we have to compress/stretch that raw desktop capture into view pixels. Okay. Because client coordinates are relative to the upper left corner of a Windows client area, the coordinates of the upper left corner are 0, 0. Next, from these coordinates, we retrieve the height and width of the desktop Windows client area in both view pixels and raw pixels. Per that value that I showed you in Windows display settings, for each direction there are 1.5 raw pixels per view pixel. So here's the API for getClientRectangle, and then we derived height and width of desktop window in view and raw pixels. Next, we allocate new array data if needed. So mat.data was already initialized by this statement involving the webcam frame capture. But if the desktop image in view pixels is different in size than the webcam image, the previous data, the webcam data, is dereferenced, and the data buffer of the matrix pointed to by Matt is redeclared. Next, we create a bitmap compatible with the desktop window that is associated with the device context for desktop window. We define a bitmap info header structure that contains information about the dimensions and the color format of a device independent bitmap, and this is an info header that will be used for retrieving the bits of bitmap compatible with desktop window and copying those bits into the mat.data buffer. But this is a non-bitmap specific bitmap info header object right now. Next, we select the bitmap compatible with desktop window and associated with device context for desktop window into the specified device context, which is memory device context compatible with desktop window. We copy the bitmap compatible with desktop window and associated with device context for desktop window from a source rectangle, which is I guess a property of device context for desktop window, and then we copy into a buffer associated with memory device context compatible with desktop window. I think memory device context might actually be a buffer. So this is a copy from basically, I think, red desktop frame to memory device context. And in the process, we compress the bitmap to fit the dimensions of the destination rectangle. So we're converting from a bitmap of raw pixels width and height to I guess a smaller view pixels width and height bitmap. Then we retrieve the bits of the specified compatible bitmap and copy those bits into the memory buffer pointed to by data of the CV mat object pointed to by mat. And we're copying using this format. It has a device independent bitmap. Then we delete the bitmap compatible with desktop window and delete the device context, memory device context. And we release the device context for desktop window, freeing it for use by other applications. So this use by other applications, I think, might be related to why darknet slows down when OBS Studio is also using this device context, copying from a Windows API desktop capture to the video that you're watching. So that was a slow code walkthrough for get capture frame CV, which is called by get image from stream, letterbox or resized, which is called by fetch and thread. Fetch and thread is passed as an argument to what looks like a darknet method for parallel threading, but I couldn't, very quickly at least, find the definition of the parallel threading method that takes fetch and thread as an argument. I'm also thinking about possibly doing serial image capture instead of partial threading, and then working with the detected objects and their positions. I'm also thinking about assembling some clusters of centers of objects or upper left-hand corners of detected objects, and then every quarter second or 1 second or so finding the appropriate number of clusters and the centers of those various clusters, and then working with those detected objects somehow. I hope this tutorial was helpful in getting a little bit into how the demo video webcam desktop capture functionality could work in your own darknet solution, and may also help you become familiar with the logic and the idioms of darknet. Darknet's a huge deep learning framework with a lot of functionality, and I've been working with it for a long time, and really just getting under the surface still. It's cool to me to be able to introduce code snippets to apply darknet, but I'm also very interested in outlining the network logic so that maybe then I can minimize the darknet solution. One last step that I'm interested in considering, maybe in a future video, is instead of capturing my desktop, how would I capture application windows? I think I'll toy with that off camera. Thanks for watching.